Hello everyone. In this video, I'm going to explain you the solution of chef and dice problem. Uh, the contest has ended, and I'm making this video after the contest ended. Um all my previous video were during the contest. It's April 15, 3 a.m. in the night. Anyway, I was procrastinating to making this video. I finally decided to make it now. First, I'm gonna read out the problem. Okay, yeah. As for the Wordy matrix problem, I did try a lot, but I couldn't complete it. But now I think, if possible, I will make a video on it. If I am able to complete it by saying other solution. I understood the problem though. Let me read out this chef and dice. Chef has n six-sided standard dice. Each die has dimensions 1 into 1 into 1. Since Chef is bored during quarantine, he decides to stack dice for fun. First, chef forms four vertical stacks of dice, not necessarily with the same height. Empty stacks are allowed on his table, which together make up a pile of dice with a base area of 2 into 2. Okay, so let me explain as I draw. Obviously, you need to know Python to understand all the solutions. And I will, on my previous video didn't have the links to the solution. From now on, I will give the links. If possible, I will also provide C++ solution. So if you know C++, not Python, then you can also refer to those solutions. Okay. So what basically the question is saying, it is, let's see, there's a dice. It has six sides of dimensions 1 into 1 into 1. And the chef decides to stack it. First, a chef forms four stacks of dice. Okay, and base area is covering a dimension of 2 into 2. So basically, it means one die over here, one die over here. Then it's 2 into 2, right? 2, this is 2, and this is 2. This is the base area. So yeah, length is 2 and breadth is 2 of the base area. Okay, among all such structures, the total visible surface area of the chef structure must be smallest. So obviously, the what visible area is uh, the all area sub, after subtracting the base area. So that means how much? 2 into 2, the top area plus all the sides. Sides have an area of 1 into 2 times 4. So this is the area if there are 4 dice and they are stacked in such a manner. Okay, then chef calculates the number of pips, and pips here refers to the small dots on the die. Pips on the visible faces of all the dice in the structure. A face of a die is visible if it does not touch the table on another die. So if two dice are in contact with each other, Uh, so these pips are not visible. So it is also saying that the face of a die is visible if it does not. He's wondering among all such possible arrangement, what is the maximum possible total number of pips? So the area should be minimum and pips should be maximum. These are two conditions which are given to us. Since he is busy cooking, he is asking you to solve this. Okay. Before trying to understand the code, you have to first we have to first understand the mathematical pattern that is going on here. If you analyze all the test cases for n equal to 4, means 4 dice for 4. Okay, let me make a new one. For n equal to 4 dice, there will be the sum of pip, not the sum of area, not pip area. Sum of area will give a certain number, A1, and the sum of area when n equal to 8 will give a certain number. And after this, n equal to 8, when we add 4 more dice over it, so when it's n equal to 4, there's only one layer. When it's n equal to 8, second layer comes in place. After the second layer, we can see a pattern. The sum of the areas will show an arithmetic progression. This would be A2 plus D. When we add plus 4, 12, and equal to, then if we add 4 more dice on it, and equal to 16, sum of area of visible surface will be A2 plus 2D, and so on. So in our code, for the first 8 test cases, we used if else, and after that, we use a mathematical formula for all other test cases. And how did I notice this pattern? Well, I tried out all such, I printed out all such cases, the area, what would be the area. Then I noticed the pattern. Let's see what would be the area of each test cases from ranging from n equal to 1 to n equal to 8. So if it's n equal to 1, there is only one die. We were given two conditions: max pip, mean area. So let's just ignore area since only there's a one pip. So it will obviously be 1 into 1 into 1. Now considering max pip, we get the max pip on the visible surface. One, the surface area of the die which has one pip should be at the bottom so that it is not visible. And as we all know, the die follows a pattern. Uh, if the opposite surface has one pip, then its opposite surface we'll have 6 pips, so that its sum is 7. Similarly, for this surface, if it has 2 pips, then its opposite side will have 5 pips, so that the sum is 7. Similarly, for here, it will be 3 pips plus 4 pips equal to 7. 21 minus 1 equal to 20. Let's check my solution first. As you can see, I made 5 attempts. I finally got the complete uh, solution after my 5th attempt. All other were partially correct. Okay, see, as you can see, when n equal to 1, the pip count is 20. When n equal to 2, we have to put the die in such a manner that the pips which are hiding, which are not visible to the eye, should be the least. So for 2 dies, die 1, if we sort the pips in descending order, it would be 6, 5, 4, 3, 2, 1. For die 2, we sort it in descending order similarly. As we can see here that 2 pips would be hidden from each die. So total 4 pips will be hidden. So if we had to choose 2 least pips from each die, it would be 1 and 2, obviously. So if we just put 1 over here, 1 over here, 1 over here, 2 over here for both the dies. So what our sum would be is 21 for die 1 plus 21 for die 2, which is the maximum pips a die holds. We got it from here. And minus 3 from die 1, minus 3 from die 2. And what our solution would be is 42 minus 3, 39 minus 3, 36. Our sum would be 36. This is the pip count. Similarly, if you try for all other uh, test cases or not test cases, all other test cases for n equal to 3, 4, 5, 6 till 8, you will see distinct numbers and you won't see a pattern until then. N equal to 1, sum equal to 20, n equal to 2, sum equal to 36, n equal to 3, sum equal to 51. You can see the rest from the solution over here. Now let's see if there is a arithmetic progression in the first 8 test cases or not. And pull up the calculator. 36 minus 20, 16. That's a 16 over here. Then 51 minus 36 equal to 15. Let's add 15 over here. N equal to 4. Sum equal to 60. N equal to 5. Sum equal to 76. 51 minus 36. 15. This is clearly 16. And if we go on like this, let's see, 5 plus 6, sum equal to 88, and equal to 7, sum equal to 99, or 88 minus 76. We see a change in pattern, and equal to 12. 99, this is clearly 11. The last one, sum equal to 104. After this, we see a pattern. This would be 5, right? Yeah, 5. So this is a weird pattern. We don't see any pattern over here. After this, when we put n equal to 9, we would see that the difference of n equal to 5, the difference between n equal to 5 and n equal to 4 repeats. So here sum will be, let's just draw let's make another tab for paint, and let's see the situation when it's n equal to 9. When it's n equal to 9. Let's draw it out. First layer of die, second layer of die, there's already how much? 4, 4, 8, plus one more die at the top. Here we got 9 dice. So for this equation, obviously in the bottommost layer, there's only the sides of the dice are visible. So all these sides would be either 6 or 5, the maximum 2 numbers. Let's consider the 6 is considered as 5, 5. Let's just draw it here. It will be how many dice are there? 4. So for each die there would be a 6 and a 5. This would lead to 44 in the first layer. Then in the second layer, we have we don't have the same situation. What we have is once 3 for 3 die, the upper pips are also visible. So for these 3 dice, it would be 3 highest numbers. So 6, 5, and 4. And for this die, it would be only 2 highest numbers. So it would be 6 plus 5. And this would give us 15 into 3, yes, 45 plus 11. So it will give us 56. Let me extend this. For the third layer, since 4 tip sides are visible, so we obviously give the first 4 maximum numbers, that is 6 plus 5 plus 4 plus 3. And this would give us 18 as the sum. And if we add all this, let's see, 44 plus 56 plus 18. This would give us 118. Let count when n equal to 4 is 118. Let count ahead from n equal to, and this is for n equal to 9, sorry. For n equal to 8, it was 104. Now, if we subtract this though, we get 14, right? We get 14 as the difference. And this same difference can be seen for n equal to, the count between 5 and it count 4. It count 5 is 76 here, and it count 4 is 60 here. It's 16. Sorry, I made a mistake. Sorry, here 5 sides are visible. There was a plus 2. So this will be 20. Plus 20, this will be 20. This will be 16. And we see a similar pattern between n equal to 7 and equal to 5 and n equal to 4. That is 76 minus 60 equal to 16. As we can see, we see a pattern like this because now we do a pattern. We make a we see a pattern like this because for the first test case, our dice, sum of dice will be behave differently. First, 6 are at top, and all the other 2 sides are also visible. So it will be 5 and a 4, 5 and a 4 like that. But as soon as we add another die on top of it, the whole pattern of this changes, and the 6 goes to side and the 5 comes over here. Similarly for all this. So after we keep on adding our die, all the 6 goes to the sides. 6 comes over here, 6 over here, or 6 5. Similarly 6 5 like this, 6 5, and our top layer becomes a similar situation. 6 comes at top and 5 comes at side and 4 comes at side. So from here onwards, we see a pattern of the 3 sides. As soon as we add another block, the same situation as we were doing in the second layer from the first block repeats itself. But all these cases aren't same as the first layer, because when we add the first layer here, 6 5 4 3 2 6 5 4 3 2 was there. The difference was the same as here, plus 20 would be added. How much will it be? Plus 20. But as you can see here in the block below it, the pip count decreases. Since initially it was 6 5 4, now as soon as you add a block over here, the 6 over here and 5 over here, and the 4 vanishes like this, and all other spots are blocked. So the pip count decreases by -4 from in the second layer and a layer below it. So the net sum becomes 16. But for the first layer, there is no layer below it, so the net sum is 20. So that is why we just see a pattern from the first layer onwards. First layer, second layer. Uh, from here we see a pattern. Obviously, I could have shortened this code if I use this formula from over here and change the values a little bit. But I noticed the pattern after doing if else condition until sum equal till n equal to 8. Then I noticed the pattern when I started doing n equal to 9. So yeah, I could have shortened the code. Let me shorten the code now itself. Let's try submitting it now. Yes, we got the correct solution now. Now let's explain the mathematical formula of what is going on after n equal to 5, after n equal to 4. So basically what I'm doing is I saw another pattern between n equal to 1, uh, 60 minus 20, n equal to 8 and n equal to 4. Here pit count was, let's see, from over here. Pit count was 1 into 104, and here pit count was 60. So if we subtract this, 60 minus 104 minus 60, we get, so let's just do it manually, we get 44. And the same situation also arises when we consider for n equal to 8 plus 4, that is 12. That means the third layer. This is the second layer. This is the third layer complete. Third layer die complete. This is the fourth layer. This is the third layer. For n equal to 8, 12, pit count would be something. It would be something. That's going to be something. And pit count here would be, as we know from here, 104. And the difference between these two is also 44. So we see a pattern over here when between the 4 test cases, the values repeats itself after addition repeats itself with a difference of 44. So what our formula was, sum 104 because in this code it was 60 and here it is 104. Since we need to add this value as it was not following the pattern, so we need to add this, and after that it follows a pattern. This condition n divided by 4 minus 2 into 44. As you can see, 44 is over here. So what we did was we took the test case from over here. Let's put n equal to 12 over here. 104 plus 12, 12 by 4 equal to 3, and minus 2 will give us 1. So all this equal to 1 times 44. So this would be give us 44 only, plus 6 plus when n divided by 4, that is 12 divided by 4. It is for the condition equal to 0, since 12 divided by 12, if 12 divided by, if we divide 12 by 4, then the remainder would be 0. This is the modulus operator. It keeps the remainder. So in this situation, we will add 44, another 44 in it. So what our sum would be 88 plus 104. It would be 219192. This would be the sum for n equal to 12. Now let's test it for sum equal to 8. We should get 104. For this, we will try this formula. Initial, we have to consider sum equal to 60, since it does not follow the pattern of this formula. So we take 60 as the base sum or initial sum, and then we add this formula to it. Now what is going on over here? N minus n divided by 4. We are checking in which layer it is. So if it is in first layer, obviously it can't be in the first layer, since for the first layer we already did we are printing the sum directly, so it won't reach over here only. For first layer n equal to 1, it will print this and get out of the for loop. Get out of the if conditions. So let's skip the first layer. It will start from second layer. Second layer, if for second layer, it would, our condition would be 2 minus 1 equal to 1 into 44. So for second layer, we will add a 44 to it, since we have seen not exactly, it is for n equal to 5. If we divide 5 by 4, we get 1. So for second layer, it would be 1 minus 1 equal to 0. Okay, we won't add anything in second layer. We'll just directly, this will turn out 0, and we'll directly add 16 to it. Let's make a new pane to show what is going on. If you understood already, then you can probably end the video and move on to the next video. If you haven't understand it yet, then I'm explaining more. For n equal to 4, sum equal to 16. For n equal to 5, what we did was base sum 60 plus checking the, according to the layer we are multiplying 44 to it, layer to difference between two layers, and for if it is a between two layers, n equal to 4 and n equal to 8. If it is the first die, then we have to add 16. If it is the second die, we have to add 16 plus how much? I think it was 76. 88 minus 76, whatever it would be. Let's calculate it. 88 minus 76, it's 12. So 16 plus 12 is 28. Sum would be 60 plus layer into 44. This whole would become 28. So I directly added 28 over here. For the third layer, third die, it would be sum for the 60 plus and layer into 44 plus 16 plus 12 plus let's see here now I could make out what to add over here. That's why for the first solution I use elif till else if condition till n equal to 8 so that I can know what is the difference that I need to add. So it was helpful. It isn't wasted as such. Uh, we are checking for now n equal to 7 means for the third die for 1, 2, 3 third die minus second die 99 minus 88 that is 11. Clearly that is 11. So plus 11. So if I add all these three, 11 plus 12 plus 16, we get 39. We get 39. And for n equal to 4, fourth die, that is n equal to 8 itself. Our sum is 16 plus n by 4, and we are doing a minus 3. Since this will come as a whole number, so the all this previous condition we were doing floor summation, floor calculation. So if it's 13 by 4, that means second layer, first die, we would get the division. If we only the single division, that is 13 by 4, we would have gotten a float value. It would be 3.2, right? 3, 12, 1, 2, 2, 4. So 3.24, but by adding the double slash, we are getting it as only 3. Only 3. And that's why we are now subtracting 1 so that it's the second layer. And if it's the second layer, we're subtracting 2 from it. For here, since second layer is already done. So all this formula is only valid for third layer and above. But for here it is valid for second layer and above. So if you put it in this way, you have to do -1, and if you put it in that way, you have to use -2 and extra -3 because when it reaches the next point 16, our sum will come, our value will directly come as 4 and not 3. For all the 15, it would have come 3. For 14, it would come 3. But for 16, it comes 3 since it's a multiple of 4. So we do a minus 3 to it since we are adding 44 over here itself. We could remove this 44 over from here and add minus 2 over here so that our formula is consistent. But anyway, I think you have got the logic now. I've explained it more than enough. If you still haven't got it, you can comment down below. I can answer it in the comment section. Yeah, that's it.